All right, so this is going to be a pretty straightforward use case for TypeScript. There's nothing fancy we're doing, but the goal of this is to essentially show the differences between JavaScript, TypeScript, and then how you can expand on using TypeScript within the Power Apps framework or within the Power Apps applications. So I've got a simple app here. It's got an accounts and it's got contacts. Nothing too spectacular. If I drill into one of my contacts, it gives me the old hello world sort of TypeScript announcement up at the top. Hello, this contact's name is Mike. It's pulling that out of here. If I were to say Melanie, and that's my wife that's staring at us behind me, save that. Let's see if it loads again. Next time it loads, it should say hello, this contact's name is Melanie. Okay, cool. So what that looks like and how we would do that traditionally in JavaScript is let's go ahead and close out of here. We'll go ahead and close out of these and up here. All right, so this is the sample app, the TypeScript sample app that I mentioned earlier that is up on my GitHub repo. So you can download that. I'm going to go ahead and open this with Visual Studio, and it's going to come up in Visual Studio 2019 by default, but we're going to do most of our work in VS Code. It's a little bit easier to work with TypeScript in that environment. So, all right, so we'll go ahead and call this TypeScript Summit. That'll be our local repository. We'll go ahead and clone that. Let's open up VS Code. And then open the folder for that. TypeScript Summit. Select that folder. All right. So here's our workspace. You can see under this .vs code, we've got a launch.json. We'll look at this a little bit closer later. This is essentially when you go up here under run and say start debugging or run without debugging, this launch.json tells the VS Code what to run. So it's a little bit different than Visual Studio. If you're familiar with Visual Studio, this is a little bit different. But this is essentially where we're defining how we're going to launch our application when we go to run it. And what we're specifically doing is we're going to be running our jest tests, so our unit tests, and we'll look at the unit tests here in a minute. But if we go to source and we just go to, let's say, our contact form.js, right? So this is how we would do what we just looked at in generic JavaScript, right? So if I go into XRM Toolbox and I look for my JS file, contact form.js, that's essentially what we just looked at, is that code. Plain JavaScript, no TypeScript, no IntelliSense. So if I said entity execution context or execution context, which is coming in on the onload, I'm not going to get anything specific about what I can do with that execution context. So if I say get form, it doesn't know what that is. But this works, and for a simple example, you could roll this pretty quick. If we look at our contact form.generic TS that's in here, so this is the TypeScript interpretation of this very simple JavaScript onload. So again, we've just got a function onload, but now we have some strongly typed parameters coming in. So rather than our generic coming in, we've got a strongly typed xrm.events.event context, and if we go ahead and the first thing you're going to want to do is open up a new terminal, say npm install, that's going to go out and pull all the npm packages that will get rid of these squiggly lines for us essentially. And while that's doing that, let's just go look real quick at the package.json. So this is where we define the npm specific packages that we're using. So we've got node in there. I think that's just based on the way I created this project, actually, we don't really need that. We've got Jest. That's going to be our unit test framework. Jest is a JavaScript unit test framework that was developed by Facebook. We've got Signin. So Signin is a mocking framework that allows us to sort of mock up functions and methods and classes and things like that that we need in order to run our unit tests. We'll look at that a little bit when we get to the unit tests. Types XRM. So this is what I was talking about earlier when we talked about the type definitions for Power Apps, for XRM, for CDS, whatever you want to call it, or whatever it's called today. This is where those types are defined. So this is an open source package that you can modify. It's on GitHub, and you get it through NPM. And then we have some more Jest. These are all the types, the @types in front of them, meaning that these are the type definitions. And then Jest, these are the Jest sort of runtimes and the editor and things like that. We've got Typescript installed, obviously. We've got XRM-mock, which is the mocking framework for XRM that we're going to use in our unit tests. Signin, Parcel, we'll look at in a second, and then our Typescript Jest package as well. So if we go back to our contact form, generic.ts, there are a lot of dependent packages as well, so that does take a while to actually load all of those, but it looks like it loaded everything. You can see our squiggly lines are gone now. That means that it's recognizing the types now. So what we can do from here is go to npm scripts, click build. These scripts are all defined in the package.json as well. And if we build that, it should build successfully. It did. So we went from a generic JavaScript, no IntelliSense, no typing, no strongly typed anything, to our TypeScript, which now has strongly typed. Obviously, there's not a whole lot of difference. This is 5 lines of code. This is maybe 8 lines of code. Sorry, wrong one. This one. So this is 5 lines of code as well. But what this gets us is if we were starting from blank, right? Now we can say let form context, and then we define this as any for now. I forget what it actually is. But anyway, we can say execution context dot get form context, and we're getting all that goodness of and it's xrm.form context. So we're getting all that goodness of the IntelliSense and the strongly typed in there. So that's great. When this built, what it ultimately built, and I said was transpiled, is the JavaScript. So under TS output, we've got contact form generic.js. This looks almost identical to our JS file up here, contact form JS, except now it's got use strict in it because we said to do that in our TypeScript configuration, which is in here, tsconfig.json. And we've got our map file. So the map file is what essentially allows you to debug TypeScript and when you're running the JavaScript. So the JS map file gives you the ability to debug TypeScript and while it's actually running your JavaScript. So that's the translation, or that's the browser will respect that, the dev tools will respect that, and the local IDE will respect that and allow you to step through your TypeScript code even though it's JavaScript that's actually running. All right, so we could take this, we could put this into our web resource. It should do the same exact thing. All right, ultimately it's just generic JavaScript. It's going to give us the same result. Let's come back here, refresh. Cool. All right, so we have a TypeScript that transpiled into JavaScript, still works, still tells us who the contact is. So now we want to take this a step further. So I want to use the same code because it's so awesome and the customer loves it, and they really want to, they want to highlight what the person's name is or the entity's name, and they just want to use it all over the place. Who knows why? So we want to do that for our account as well, right? So we've got our account, and what we could do is we could say, okay, well, let's take contact form.ts, we'll copy and paste this over here, boom. All right, and then we just got to change up a couple of things. We want name instead of full name, but we're not reusing the existing code, and that's a problem, right? Long term, that's not going to be manageable or maintainable. So what we're going to do instead is we actually want to get some code reuse, and we want to sort of make this more generic. So instead of copying and pasting what we already have, we created a form common. So we have a sort of a utility class here. These are all static classes. You can see that we're exporting a class called form common, and it has a static method in it. We're not going to be, when we're calling these things from the form, we're not going to be instantiating instances of classes, Typescript classes. We're going to be calling them directly, and that's why all of these methods are static, and there's not really a inheritance structure in this. However, you can do inheritance with Typescript, but in this it's mostly just static methods calling each other. But we do get that code reuse here. So we've got and this will look familiar to any object-oriented programmer. We can export the class, meaning others can consume it or import it. We've got a static method here that's public called getHelloPhrase, and we've parameterized a string with the entity name as well as the attribute for the primary field name, and we're going to pass that in to this function or method in our classes. So if we look at our account form.ts, we've got again an exported account form class, and when you export a class, it becomes a module. And what you can see up here is we're importing our form common module. So we're importing the form common because we exported it in the form common file. You can see that's pointing to that file we were just looking at. We're exporting this account form. We've got a public static onload, and we've got all the goodness of strongly typed going on here. We're calling into the getHelloPhrase that's in form common. All good. We can do the same thing in our contact.form. We could actually probably make this even more generic, right? We could take all of this and move it into our form common. So I could almost say, okay, well, let's make this just onload, right? And then in our contact form, we're just going to call form common dot onload. And what does that want? It just wants, let's say it wants the same thing as this, execution context. And it also is going to need primary name. All right, and then let's go back over to form common. This is now our onload. So instead of form context, I'm going to get the execution context into this and the primary field name, and then I can take all this code, get it out of here, put it into here just like this, getting the form context. All right, so now form common has all of this code, and contact form.ts doesn't need all of this. It doesn't know what getHelloPhrase is. Another nice thing, so now we're getting build errors because getHelloPhrase doesn't exist anymore in form common. So compile time, we're going to get an error because we changed this. So we'll just leave that as form common.onload, and then in account form.ts, we'll do the same thing. And instead of first name, we're going to just do name. All right, so now we're getting even greater reuse out of our code. We've got a single place that has our hello world onload function or method, and we can do all of this within here. This should be, we'll make this void because we're not returning anything anymore. And let's go ahead and build that. All right, so that built. Let's go take a look at what that produced. If we look at CS output and go to, you can see we have our form common here now. So all of that code that we put into our form common actually shows up in this form common.js. If we can look at our contact form or our account form.js, you can see they look a lot different than what we were looking at before, even for our contact form generic.js, just a couple of lines of code, as well as our as our straight JavaScript. So what do we do with this, right? So now we're getting into a little bit of uncharted territory with TypeScript. So what I could do is, let's go ahead and copy this and we'll put it into our contact form. So here's our contact form. We've got some strange looking things in here. We've got to use strict, but we've got this define property ES module. You can see now we've got a requirement on this form common, which doesn't really exist in our web resources, so that's probably going to fail. And then we've got this exports contact form. I guess that's our class, right? And then and then ultimately here's calling the onload. So if I save this and publish it, chances are it's going to fail miserably. Let's see. Let's just Control F5, see what happens. Yeah, there we go. Okay, so first thing to look at here is, well, onload does not exist. Well, that's a problem. Okay, so we don't have an onload method. If we were to try to fix that, maybe we could, let's go back to our form. So we'll go to contact. And we did see, if you look at the JS, so now it's exports.contactForm equals contact form. So let's try that. Let's go to forms, contact, and switch to classic so we can edit our JavaScript. So maybe if we just do, instead of onload, let's say, was it exports.contactForm.onload? Maybe that'll work. It's not going to. I can tell you that now. So this is, I mean, these are some of the things that you'll, if you were starting from scratch, you would run into. That's going to fail. It's going to say the same thing. It has no idea. Yeah, it has no idea what that is. Okay. So how do we get around this? How do we use modules within TypeScript and be able to deploy a single web resource? So the other things that we had tried when we first went down this path was to, okay, well, maybe we put formcommon.js in there. We load that before contact form in the web resources for the form, and then hopefully it gets the context of what form common is, and then we can go from there. So that didn't work. Ultimately, what you need is a bundler. So if you're familiar, those of you who are more familiar with the client-side scripting and bundlers, Webpack is one that is used very frequently when trying to bundle resources together. So you've got a website, for example, and you've got HTML pages, you've got JavaScript, you've got CSS, and other resources essentially that you want to include. And when you're doing a website, that's fine because you can load those resources from a directory, and you can include them with statements in your header in the HTML and things like that. But what Webpack and other bundlers do is it kind of takes all of that stuff and puts it into a single file for you, so you can deploy it as a single asset, and you don't have to have all those dependencies and things like that. So the bundler that we're using in this project is called Parcel. We had we saw that when we were looking at the package.json. The reason we're not using Webpack for this is Parcel is very quick to use and configure. Webpack has some more configuration ability than Parcel does, but Parcel is very simple to use and simple to get started with. So if we look at our package.json here, you'll see there's two scripts in here. So there's a Parcel dev and a Parcel prod. The only difference between these two is the Parcel dev does no minify, so it leaves the JavaScript unminified so that it's easier to read, and it can be, and when you're running it in the browser and in the dev tools, you can format it and it looks nice and it's got the same variable names and things like that. And if you minify it, then it's a little bit more difficult to debug, but it has a lower footprint because it's smaller. So essentially this is it, right? So we're calling Parcel, we've included that as a npm package. We're calling build, we're pointing to an output folder. So our output is all of our, we want to pack all of our, or parcel all of our JavaScript files in our output. We've got a global namespace that we're including here. So in this case, if you download this and you're using it on your project and your company is Excellence, you may want to make this Excellence, right? So that just gives it a global namespace so that there's no conflicts, and there's no conflicts once you deploy it. And I'll show you how that comes into play when you register it in Power Apps. And then your output directory, we've got an output directory called Parcel Distribution, Dev, MS, etc. With no minify specified. And this should actually probably be prod. We want the prod one to go to prod. All right, so to run that, we run Parcel Dev. And that'll go in, and Parcel will actually go in and parcel up all of our JS files. So those get output to that directory. And now if we look at our contact form.js, it looks even more unreadable than it was before. However, it will now actually run within Power Apps because everything's been included in this, including our dependencies, our modules. So if I look for base form, what is our, let's just look, source, it was our form common. So I look for form common, right? So nested away in here in our parceled up JavaScript is a reference to the form common, and it pretty much takes care of everything for you. So now this is actually a deployable JavaScript file for Power Apps. Let's take it and let's throw it into our web resource. I get the right one, contact form.js. Save that. Obviously, we took 5 lines of code and turned it into a lot more than 5 lines of code. So the minifying when you're going to production is a good practice, so that you're not having these huge JavaScript files that need to be pulled down every time. But let's go back to contact. Control F5 again. Oh. Publish that. Oh, okay. So I did forget a step here. So I actually need to update when we change it to exports.contactform.onload. So I need to update that. So it's not exports.contactform.onload. It's actually our global namespace, which is mf Mike factorial.contactform.onload. Save that. publish. Okay, so let's go back and look at our account, our contact. Load that up again. Okay, now we're back to this contact's name is Melton. Good. Let's do the same thing really quick for the account so we can see that happening. This is TypeScript sample. We'll go to account. We'll actually want to create a new web resource for our account. This will be js/account form.js. Script, English, choose file. So here we are, no longer in that repo. We are in the Summit repo, and if we go to parcel distribution, dev mf.js, and we want our account form. Save and publish, and go back to our account form. Switch to classic. So if we go back here, just real quick, you can see. So you can see there's no tricks up my sleeve here. If I open this account, we're not going to see our message up here. But then if I go in here and add account form, and then on load, we want to do mf.accountform.onload. We want to pass the execution parameter into that. Click OK, save and publish. All right, refresh. There we go. So now we've got code reuse. We've got a single sort of base form to do the same functionality, and and get that good code reuse. All right, so that's TypeScript in a nutshell, and how you can use modules in TypeScript. What we're going to look at next is unit testing. So as I mentioned before, we're using the Jest framework for unit testing. And if we go to our source folder and we look under tests, you'll see we have an account form test and we have a contact form test. These are pretty much similar. I didn't go to a lot of trouble to sort of put a lot of reuse into this. They both are pretty much the same. But if you look at what we're importing as well as what this is doing, so we're importing the XRM mock framework, and that mock framework is a framework that essentially mocks the XRM client-side APIs and the client-side types. So XRM mock, also open source, also able to be contributed to. It has some limitations, but one of the other things that we're using in this project is sign-in, which I talked about earlier, which you can stub out some of the limitations. So if there's certain functions in XRM mock that aren't handled by XRM mock, you can actually stub those out and using sign-in, S-I-N-O-N, and kind of roll your own on the fly. Or you can, do a pull request into XRM mock to get, get any of those things that aren't implemented. So then we're also importing our account form because it's a module we exported. We've got this test initializer, which is a sort of utility class, again, same as what we were doing before. And in our Jest tests, we're describing our account form, and then there's a before each and a before all. So you can you would essentially run this before each of your tests, each of your unit tests, and then the before all would run before all of the unit tests in this description. So our before each, and again, the niceness of TypeScript, we say go to definition, it goes directly to our definition. We are passing in the entity name, so we're essentially telling this XRM mock generator to initialize and the entity name that we're working with. So in our account form test, we're passing in account. In our contact form, we're passing in contact. Down here, we have a stub for our set form notification, which is that call that we're doing that sets the banner at the top of the form. XRM mock does handle set form notification. Unfortunately, it doesn't give us any way to get back the form notification that we set in our TypeScript. So we're mocking that. We're essentially stubbing out that set form notification, and just whenever that set form notification gets called by our account form JS or our contact form JS, it's going to call this method instead. So that takes a message, it takes a string or a unique ID, and it returns a Boolean. So all we're doing, we've got a map up here, which is essentially a dictionary that takes a string key and a string value. We're adding our unique ID and our message to that map, and then we're returning true. So if we look at our account form test, you can see the XRM mock will generate an event context for us, and we can get rid of this, that doesn't need to be there. We can create attributes. So when we create a attribute using the XRM mock generator, we're essentially adding forms to or adding fields to a form. So in this case, we're adding the name field to our account form. In the case of the contact, we're adding our full name to the contact form. This is a create string. There's also create lookup. There's create pick list. Other types of fields that you can essentially mock up, without ever having to deploy this code into Power Apps. From there, all we're doing, contact form.onload, we're directly calling our contact form onload static method with our mock form context, and then we're looking to make sure that the form notification size is 1 and that the first value that is returned contains the value Mike Ox, which is what we want because that's what we set full name to. And then likewise on the account side, making sure that that first value contains excellence. So I'm going to build this again, and we can run our tests from here. And what's again nice about being able to run the tests from within VS Code is we can actually debug our code. So if I click start debugging, say allow access here. Alright, so we've hit a breakpoint here. If we look at our form context, and by the way, if you're debugging in VS Code and recording with Camtasia, F10 cancels the recording, so but it's also what I use generally to step over code, so just beware. Alright, so here we are. If we look at our form context, we can see what controls are in the collection right now. There's none. There's 0 in there. I'm not going to hit F10. I'm just going to step over with the button so I don't cancel the recording. And now if we look at the form context, we can go in there, the UI, controls, we've got 1 in there now. So we've got all the debugging capability that we need from within here. And if we wanted to step into our form common, for example, let's just put a breakpoint there, not there, there. I don't know why it wants to go there. So now we can see what our hello string looks like. Okay, the account's name is excellence, great. And we can continue on our merry way. We should be getting output from this in the debug console. I'm not sure why I'm not right now, but you should be getting what tests failed, what tests succeed, etc. Out of this console, and it was doing that earlier, but for some reason it's not right now. But in the interest of time, I'm going to actually jump over and wrap this up with how we can integrate this into Azure DevOps. So if you're doing unit tests on your plugins and things like that, and you're not currently doing unit tests on your JavaScript and TypeScript, the ability to integrate that into a pipeline, get your code coverage results out and publish those to, for the team to see, or for an executive staff to be able to see, if they have a mandate for a certain amount of code coverage, is pretty powerful. So just real quick, I'm gonna go jump over to our Azure DevOps, and we're gonna actually pull the code from our GitHub repo. I've got one set up here already, a pipeline set up. And you can see I actually 54 minutes ago I checked something in to this, so that was right before we started. But you can see that it actually recently ran. I had some errors 2 hours ago, but got it working just in time. So if we drill into one of these, you can actually see the results, and you can see those test results specifically. So we've got 100% of tests passed. And you can see 2 total tests. So those are our count test and our contact test. But I'll just show you real quick how I set this up. It takes like no time at all. If I create a new pipeline, I'm going to pull this from GitHub, and I wanted to pull from my Power Apps TypeScript sample. I set this up as a Node.js project. That seemed to work okay. It does build TypeScript, or it does the npm install, and then it does the npm TypeScript build. So that seemed to work fine. Maybe a better way to do it, but as a template, this seemed to work. The only thing that I wanted to add then, so we've got npm install, we've got npm run build. I want to go ahead and run my. Let's just save this first. Save it. And I'm committing directly to the master branch because I can. Maybe I shouldn't do that. But if we want to edit this, so we can come in here and let's just look for npm task and click npm. I want to run a custom script from here, and I'll actually have to look at the arguments on the other one in order to do this, so real quick, bear with me. And let's go to the pipeline. It's this one. Click edit, and there it is. Yeah, that was pretty straightforward. So it's just run script tests. There we go. And if I wanted to do this from the editor, I could do that as well. So instead of here, just paste that into here. So here's our command, npm, or run script test. There we go. Looks the same. Probably give it a nicer name than that, but it works for now. Let's save it and commit it, and then we can actually run this, and if all goes well, it should go ahead and build our project and run our unit tests. It's pulling the code, it's installing Node, which we may not need, but then it's doing an npm install, which is what we did initially when we pulled the branch down into VS Code. We had to do the npm install, and then we ran our build script to build it. Again, quite a few packages being installed. We only had like 9, I think, 9 or 10, really, that we installed, but there's a lot of dependencies on those. So, and there we go. All right, so 100% test passed. There you go. And now we've got an end-to-end TypeScript solution with unit tests and using modules and running our tests inside of Azure Devops. So we could potentially manually deploy this through our pipeline. If you didn't want to just deploy it through your solutions, you could do that. Generally, the way we've done it is to deploy it through solutions. So once we push it up into our solution, we'll generally just push it out that way as well, because we'll unpack it, put it into source control, and we know exactly what is going out in the solution. But the ability to run the unit tests in Azure in the DevOps pipeline is critical for us and for projects that I've worked on, because then you can fail a build based on those unit tests. So, all right, just jump back here to, and it looks like I lost my